11.3 is on inscribed angles. We're going to start with a few warm-up problems. The number one warm-up is that the measure of the interior angles of a quadrilateral are 80, 100, 55, and 5x. They want us to find the value of x. So if you remember back to our quadrilateral unit, all of the four angles in a four-sided shape always are going to add up to 360 degrees. So we're going to take these four angles, add them together, and put it equal to 360. And if I grab my calculator here, we can start by combining like terms, 80 plus 100 plus 55, and that will give us 235. And we still have the 5x equals 360. Then on both sides, we're going to subtract the 235, and that gives us 5x equals 125. And our final step, divide by 5, and that will give us 25 for our answer. Our second warm-up problem is a review on supplementary angles, which means that they add up to 180 degrees. So they have a measure of 6x and 12x. So that means if we were to add these two angles together, because they are supplementary, they add up to 180. So when we combine our like terms, we'll get 18x equals 180. And when we divide by 18, we will get x equals 10. The important thing for these types of questions is that you read all of it so you know what you're going to answer. So this one, they want the measure of each angle. So we're just going to plug our x value, 10, into each of the angles, and then we will get that one is 60 degrees and one is 120 degrees. For number 3, we're reviewing a little bit of solving equations. So when you have parentheses with a number out in front of it, we are going to be distributing. So if we take half of 4x, that's going to be 2x. Half of 12 is going to be 6. Then we are solving for x. 3x minus 2x is just x, and we're left with x equals 6. And this one, the only direction was to solve, so we are done with that. Okay. The next piece is new vocabulary for this chapter, or for this section. And we have two new words, inscribed angle and an inscribed arc. So we're going to draw an example of what an inscribed angle looks like. And what that is when you have a point on the edge of the circle, it's the angle formed going to the opposite side. Opposite side of the circle. So this is an example of an inscribed angle. It's the angle formed here. So before we talked about central angles, and central angles had to have their vertex on the center. So inscribed has to have their vertex on the circle. So then the next part is the intercepted arc, and that is the distance on the circle, so the curved part, that's intercepted by this angle. So this portion here in between the two endpoints of the angle is the intercepted arc. And remember, arcs are the curved part of the circle. Okay. Using that, we are also able to have an equation that helps us find the angle measurement or the arc measurement. So for this one, the inscribed angle that one is going to be 1/2 the measure of the intercepted arc. So we're just going to take 1/2, and if we know the measurement of the arc, we are just going to multiply it by the 1/2, and then we'll know what the angle measurement is. So then, if we weren't looking for the angle, if we were looking for the arc, Yeah, the intercepted. That is going to be equal to 2 times the inscribed arc. Now, both of these equations are the same. They are just rearranged depending on what part you are solving for. So if you're going from the arc to the angle, so you're solving for the angle, you're going to multiply by 1/2. If you're going from, oh, I wrote that wrong, I'm sorry. This is supposed to say angle. So if you're going from the angle to the arc, then you're going to multiply by 2. Alright, so let's do some practice for what that looks like. The first one, they want us to find the measure of angle T. So that is going to be this angle down here. So looking for the measure of angle T, we know that it's an inscribed angle because the vertex of the angle is at the edge of the circle. And we know the measure of the intercepted arc is 48. So because we're looking for the angle, that is going to be 1/2 of the arc measure of 48. And if we take half of 48, that's going to be equal to 24. And it's an angle, so don't forget to label it with degrees. For part B, if you could, we'll leave it. Part B, they want us to find the measure of QR. For now, we're going to leave it, but in order to find QR, we're going to have to find some other pieces. So if you notice, this is cut by a diameter. So all of this up at the top has to be 180 degrees. We don't have enough information right now to find QR, but we have enough with this inscribed angle to find QT. So the measure of arc QT is twice or 2 times the measure of the inscribed angle that cuts it off, so 2 times 50. And that will give us 100 degrees. So if the whole thing has to be 180 and this portion is 100, to find QR, we're going to take 180 minus 100. And that's going to give us our measure of 80 degrees. Remember, arcs are the portion of the curved part of the circle, and they are also measured in degrees. Okay. Our next one, they want us to find the measure of RS and then the measure of STR. Okay, so if we start with the measure of arc RS, that would be this portion right here. We do know the inscribed angle is 31 degrees. So because we're looking for the measure of the arc, we're going to take 2 times the angle, or 2 times 31. And that's going to give us 62 degrees. The next thing, they want us to find the measure of angle STR. That angle is an inscribed angle, and it is cutting off an intercepted arc, which we just discovered was 62. So to find the angle, we're going to take 1/2 times the arc, which is 62. Half of 62 is going to be 31 degrees. And they wanted us to see what we notice about angle STR and angle RUS. And RUS is this one over here. Those two are congruent angles. And the reason that they're congruent is because they cut off or intercept the exact same arc in the circle. So the reason we did this problem is to go over this property. If 2 inscribed angles of a circle intercept the same arc, then the angles are congruent to each other. So anytime they intercept the same arc, they are congruent. Okay. So then for our next example, we're going to do some practice. In number 1, we're looking for this angle G. It's an inscribed angle because it's on the edge of the circle. So we know that that has to be equal to 1/2 of the arc it intercepts, or half of 90. So for this one, it will equal 45 degrees. Then for number 2, we are looking for the arc measure. The arc is cut off by an inscribed angle. So we can say that the arc is equal to 2 times the measure of the angle, or 38. And that's going to give us 76 degrees. In the last one, number 3, we're looking for this angle up here on the right side. And you'll notice that the angle they give us is 72 degrees. The angle we're looking for, those two angles cut off the same arc. So whenever they cut off the same arc, that means they are congruent to each other. So for this one, all we have to do is put x is equal to 72. Right. The last part, or last two things we're going to go over, is a polygon is an inscribed polygon if all of its vertices lie on the circle. And that's important that the vertices are on the circle, because then we're going to be able to use some properties to help us figure out some missing pieces. One special property is that if it's a triangle inscribed in the circle and one of the sides is the diameter, then we are going to have a right angle, or a right triangle. And if you look, the longest side on this triangle is the diameter, and that's always going to be the case when one side is the diameter, which means that the angle across from the diameter is going to be that 90-degree angle. That's important to know so that we can use Pythagorean theorem to find any missing pieces. And then the last one, if a four-sided polygon is inscribed or in the middle of a circle and all the vertices are on the points, then the opposite angles are supplementary, which means they add to 180. So if we use this image below and we were to list the pairs of angles that would be supplementary, it's the angles that are opposite of each other. So angle F and angle D are supplementary. And if we look, the second pair would be angle E and angle G. So they are going to add up to 180. All right. For number 4, we are going to practice what we just went over, that opposite angles are supplementary. So in this one, 75 plus y has to equal 180, and 80 plus x has to equal 180. So once you have those, we just have to solve the equation. To solve for y, we're going to subtract 75, and that's going to give us 105. And then to solve for x, we're going to subtract 80, and that gives us x equals 100. Looking at our next diagram, we have two opposite angles, 4b and 2b. We can add those together, and again, they have to equal 180. Combining our like terms, we'll get 6b equals 180, and if you had to divide by 6 here, you would end up with 30 being your answer. If you look at the last two angles, these two are the same thing, and that's okay. That will happen sometimes. So we're going to have 2a plus 2a equals 180. And you want to make sure you're being careful that you're adding these together. You're not multiplying. So 2a plus 2a is going to be 4a. And then we would need to divide by 4 on both sides. And that's going to give us our answer of 45. Right. So if you have any questions on this section, just let me know, and I will get those answered for you.